In this video, we're going to talk about finding the real zeros of polynomials. So I wanted to show you that you already know how to find the real zeros of a linear function and a quadratic function, right? Those are polynomials. So just for example, if you had a linear function like 2x minus 6, to find the zeros, remember that that means solving for x, um, or it means setting the function equal to 0 and finding the x. And the zeros are also known as the roots of the function, and they are also the x-intercepts, right? So we could set the function equal to 0, solve for x. If we had a quadratic function, we do have to do a little more work, right? We would set this function equal to 0, but we would still be then trying to solve for x. We would either use the two methods that we have, which would be factoring, and if we figured out that it wasn't factorable, then we would use the quadratic formula, right? So we have some strategies for both of those. Now, really what we're going to be talking about in 5.2 and section 5.3 is what about larger polynomials? So third degree, fourth degree, fifth degree. How do we find the zeros for those? How do we factor those? And then also, how do we find the zeros for them? So in this section, we're going to be talking about the real zeros. And that means they're going to be real, rational, or irrational numbers. And then in the next section, we're going to be talking about complex zeros. So complex zeros could include numbers that are not x-intercepts, but they are imaginary, they have an imaginary portion of them. All right, so if we take a look at this problem, the first thing that we need to figure out is, well, how many possible zeros are there, right? So we hopefully have already learned in 5.1 that there could be up to 3 real zeros in this problem, because it's always you have the same number of zeros possible as the degree of the function, right? So the number of real zeros is less than or equal to the degree of the function. Okay, so in other words, the degree is 3, so we could have 3 real zeros, 2 real zeros, or 1 real zero. Yes, exactly. And the total number of zeros is going to equal the degree of the function, but some of the zeros may be non-real numbers, and so we won't look at those until section 5.3. All right, so what are those zeros, though? To find them, the first thing we're going to do is let's list the possible real or rational zeros. So first, to find zeros in this polynomial, the first step we're going to do is list possible rational zeros. Okay, and the way that we do this is plus or minus P over Q. And P is the factors of the constant term. Okay, in other words, the number that does not have an x with it, so in this case, -6, okay? We have to consider that number, because if we were in factored form, right, that number would be all of the constants multiplied together, and then the Q is the factors of the leading coefficient. So the leading coefficient in this problem is 2. It's the number next to the x with the highest degree, right? And so this also needs to be taken into account for any possible zero. They need to have a combination of the last term and the first term involved. And we're not going to go into like the full details of why that is. So for example, Okay, for our example, f of x is equal to 2x cubed plus 11x squared minus 7x minus 6. Okay, so in our example, p is the factors of the constant term, and so the p is equal to, for negative 6, right? So plus or minus 1 plus or minus 2, plus or minus 3, and plus or minus 6. They are, again, the factors of negative 6, which is the constant term, and q is the factors of the leading term, that 2. So plus or minus 1 and plus or minus 2. And those are, again, the factors of the 2, which is the leading coefficient. Okay, so the possible rational zeros come from plus or minus p divided by q. So in our problem, that's all the p's divided by all the q's. Now you'll notice that the q's start with 1, so we have plus or minus, and then all of the p's, because they would all be over 1. So plus or minus 1, plus or minus 2, it's like 2 over 1, plus or minus 3, plus or minus 6, that's just, again, 6 over 1. And then we have to put all those p's, all 4 of them, over the 2 from the q, okay? So that only leads to a couple more possibles. So that's plus or minus, and then that would be 1 over 2, so 1/2. Plus or minus 2 over 2 is already there, it's 1, right? Plus or minus 3 over 2 is a new one. And then plus or minus 6 divided by 2 is just 3, so that's not a new one. So these are all the possible rational zeros that we could find from this equation. Now, that doesn't mean these are the factors or the zeros of this equation. That's way too many, right? Didn't we say there's only a possibility of 3 real zeros? So only a few of these are going to be the right answer, right? But these are the list of all possibilities, okay?